Hi, my name is Jennifer Swanson. I am the author of Save the Crash Test Dummies, the history of car safety engineering, brought to you by Peachtree Publishing Company. So what I'm going to do today is I'm going to read a little bit from my book, and then we're going to do some really fun activities with cars and learn all about the laws of motion. So before we start, you might want to go grab a couple of materials. First of all, see if you have any big marshmallows like this. Small ones work too. If you don't have a marshmallow, you just need something that's going to act like you. So it could be a coin, it could be a tiny ball. Let's see, it could be pretty much anything you can think of that you're just going to put on top of your car and watch what happens to you as you're in the car not wearing a seatbelt. The other thing you need is, of course, cars. Now, you can have fancy cars like the ones I have here, or you can have little Hot Wheels like this, okay? Or you can have boxes or anything that you can just kind of push together to simulate an accident, because we're going to work on what the forces in motion happen during an accident. Okay, so now I'm going to read you just a tiny little bit of my book, Save the Crash Test Dummies, with permission from Peachtree Publishing Company. Here we go. You probably don't think much about safety when you climb into a car. You buckle your seatbelt, and then you just assume that all is well. It might surprise you to learn that it took decades to create the relatively safe vehicles you ride around in today. Early cars were downright dangerous. They didn't have bumpers, seatbelts, airbags, or even mirrors. Fortunately for us, the problems the engineers recognized the problems and set to work fixing them though some of their solutions were rather unusual and at times amusing. And some of those pictures are in the book. Save the Crash Test Dummies will steer you through the history of car safety engineering, offer you a front seat view of the science and engineering that has made the world's most important vehicle, the car, much safer. But it hasn't been the smoothest journey. Along the way, there have been numerous experiments, thousands of crashes, and a wide variety of crash test volunteers, both mechanical and human. Now, I want to introduce you to the very first crash test dummy. Actually, this is not the first version of it, but as you can see, this is Crash. And as we refer to it, the crash test dummy family, you can see the mom and the 3 kids. And don't forget, let's see, over here, there's the crash test dog right there. Now, why do you think they would have crash test dummies of different sizes? What do you think about that? You're right. Because human beings are different sizes, and the engineers need to understand what each person in the car, the kind of forces that they're going to feel if they're in an accident. Okay, so now what we're going to do is I'm going to move the camera down so you can see my cars. Hopefully you have grabbed your own cars. Let's move things a little bit this way. Okay, so hopefully you have your cars set up. For this one, I'm going to use kind of the two big cars. Again, you don't have to have big cars, but this just makes it easier for you to see what I'm doing. Okay, so the first thing we're going to talk about is Newton's first law of motion, which states an object at rest will stay at rest, and an object in motion will stay in motion unless either is acted upon by a balance force. Let me show that. There we go. Now, you see this website, physicsclassroom.com. That is a great place to go for all types of physics, particularly the laws of motion. So you can go ask your parent if you can go there and take a look at this too. All right, so what does this mean? Let's see this in action. So what this means is I'm going to take one car here. So you will notice right now that car is sitting still. So that is obeying Newton's first law of motion, because if it's at rest, it's going to stay at rest unless a force acts upon it like this. What was the force? That was my finger. Okay, so everybody can try that with their car, and you can see. And also, you can try hitting it harder. You just tap it, and it moves a little bit. But if you tap it hard, it's going to keep going. Now, what slows it down? Actually, another force is called friction, which is working on the tires. So when the tires hit the ground, they slow down because they lose part of their energy. Okay, that's called friction. Or, as we use, is brakes, hopefully. Okay, so we're going to talk about what happens during a crash in Newton's first law of motion. So, if this car is just driving along, watch what happens when the car behind it hits it. Boom. Okay. Now, sometimes if they're stopped, the cars will actually brake, right? That's where you get everything dense up and so forth. So depending on how fast these cars are running together, if one is at the stop sign and another one just taps it, that's all that's going to happen. But if they're both going at about 70 miles an hour, you're going to get something like this. Boom. So try that with your cars. Try using different forces, like push really hard or push just very lightly and see what happens. Boom. Okay, now, what happens to you when you're in the car? Well, I have this fancy little thing, which you probably don't have one of these. Let's turn around so it's the straight way. Now, if you look at this, okay, this is the car. Then there is a string with a cork at the top. So the string or the cork, assume the cork is your head. Okay. So what we're gonna do is we're gonna look at the forces that are happening to you as the car is hit. So watch what happens to the cork. Right now the cork is just sitting still, right? Ready? Watch it. Oh, what happened? Did you see the cork go like this, back and forth? Let's try that again. Unfortunately, I can't slow it down, but maybe I can do this. Boom. Oh, now you can see that. Let's try one more time. So this is what normally happens. Boom. You will go forward and then you'll come back. It's why people get, I'm down here now. It's why people get whiplash. Your head goes forward and then it comes back like that. Okay. So that is all Newton's first law of motion. Now, Newton's second law of motion, this one is a little bit different. This one says the total force is equal to the rate of change of momentum over time. So this is F equals ma. Force equals mass times acceleration. How does this work in car crashes? There we go. Now we can see. The bigger the mass, so the heavier the car, the faster its acceleration, the bigger the force of the impact. And this is another website here that you can look up, thoughtco.com, the physics of a car collision. Just do an internet search for that. So this means that the bigger the car, the heavier the car, the bigger the collision, which is true when you think about semis. Okay, so now I'm going to get my big old car here. You can use the same car you have, or if you have a bigger car, that works too. See, now look at this. I have, can you see that? There you go. I have my big minivan and this little tiny car. Okay, let's see if I move it back a little. There you go. Now you can see. Here's my big minivan, and I'm going to hit this poor little car. Boom! You see? Did you hear the collision? Boom! Okay, so that's what happens when you're looking, or when a semi would hit you, or a car that's bigger than you would hit you. It's going to hit you with more force. Also, if it's going faster, it's going to hit you with more force. More than likely, it's going to bang up or crush in the back part of your car. And remember what it's going to do to you? It's going to send you forward and then back if you're hit from behind. If you run into something, if you run into something, it'll be the same thing. Okay. So now, Newton's third law of motion. Here we go. Let's see if you can see this better. For every reaction, there is an equal and opposite reaction. And there's another link from physics classroom that you can take a look at. And I also want you to take a note of these at the bottom. If you want to watch actual car crash videos instead of my little car crashes here that you're trying to replicate, go to the Insurance Institute for Highway Safety. They have tons of really cool crashes where you can see these things in action, and they have real crash test dummies in their cars. Okay, but all you're doing here with me is you're trying to repeat all of these car crashes that I'm doing. So now you need a wall. So you can use an actual wall, or you can use books. I'm going to go back to my smaller car here. So what does this mean? So for the Newton's third law, we said that for every action, there's an equal and opposite reaction. So if this car is moving forward, okay, and it hits a wall, it bounces back. So what happens is as the car hits the wall actually hits the car. Now, does the wall move? No, but it's providing a force because it bounces off. Boom, just like that. Now, the same thing if you hit your cars like this. Okay, let's look at the cars. Move the wall a little bit and watch what happens to the car. Boom. Now, it's hard to see. Let's see if I can hit harder. But this second car should actually bounce back a little bit that way, potentially. Sometimes it does, okay? It depends on where you're going. If the car is applying brakes, it may not bounce back. It may just keep going. But you'll notice that this car gets moving forward. Why? Because there is an equal and opposite reaction. So when you have a force that goes forward, you're going to have a force that comes back because the energy is never goes away. It's all used. Some of it is absorbed by the wall and some of it pushes the car back. So those are Newton's laws of motion. So why do we care about this? Now, what makes a car safe? Well, so we've added all of these things to help humans when they're inside the car so that these forces don't act upon them. So we have airbags, we have seat belts, we have a safety cell, we have interlocking brakes, which prevents the car from skidding, and we also have a crumple zone. So the bumpers on the front and the back are designed to crumple in to keep the human inside safe. So now we're going to go back to our cars. Let's see. For this one, I'm going to use the little tiny Hot Wheels cars because these work best. And we're going to take your marshmallow or whatever you have, your penny, your ball, and put it on top. And you're going to watch, see if you can kind of get it to stick there. You're going to watch what happens to you when you crash into a car. Oh, let's see. This marshmallow might be a little sticky. Boom. Oh, there you go. This is why you wear seatbelts. Okay? Boom. And if you're here and you're hit from behind, you're going to go backwards. Okay? So that's something that you can try. So you can do all of these different experiments. You can try it with the big car. Let's see. The big car hitting the little cars and see how far that sends you. And you can measure all of these different things if you want to. You could, depending on how much experiment, you can actually have a starting line, like put a piece of tape on the ground and have a starting line, and then measure how far the car moves when you hit it, how far back you fell. You can do all of these different things with your car to get all of this, information, which is exactly what the engineers do when they're getting all their data, because they're trying to figure out exactly what they're doing. Okay, so have fun playing with that and writing all of your stuff down. Here are a few more resources. You can go to my website, jenniferswansonbooks.com. And I have a couple more videos on other books. And also there's a really cool, I did a really neat book trailer that goes with this, where you can see a little bit of a couple of pictures of the old time cars. There's also a teacher guide that goes along with this book that has more stuff in it. For more resources on car safety, these are a couple of websites that are really good to go to. We have, this one is a BBC one. This has more crash test videos. And for those of you parents who might remember the Crash Test Dummies commercials from a long time ago. These are really fun to watch. Okay, so I hope you enjoyed. I hope you have lots of fun playing with your cars and learning all about car safety history and how crash test dummies work. So go and have lots of fun with science. Bye.